Hi everyone, welcome to part 4, the fourth video for our Unit 6 note packet. Today we get into target 16, so it's a new learning target. It doesn't just deal with the Pythagorean theorem anymore, although definitely that kind of thing still exists in all right triangles, but now we're going to talk about a different skill today. And our skill today is really going to be about pattern recognition. And what I mean by that is we're going to give you two specific kind of triangles, and their side lengths are linked to each other. So if you know one side length, you can figure out the other two missing sides because we know the pattern of how those other sides grow. And so those two different types of triangles are called 45, 45, 90 triangles and 30, 60, 90 triangles. And we're going to need to be able to recognize these. So let's start talking about recognizing them and the patterns that show up. Now, when you see the numbers 45, 45, 90, what that's talking about are all three of the angles. So there is a 90-degree angle in this type of triangle. So I'm going to put our 90-degree symbol down in this triangle. And then both of the other angles are going to be 45 degrees. So I'm going to put a 45 in each one of those. And what happens when we have a 45, 45, 90 triangle is that we obviously have a right triangle, but it is isosceles 2, meaning two sides are the same. And those sides are the sides that are across from our 45-degree angles. And so I can put my congruent tick mark through these two because I know those sides are going to be the same length. We call the congruent sides legs. So that's a leg, and this is a leg. Now, as we talked about a bunch of times before, across from our 90 is always our longest side, and it is called the hypotenuse. And so those are our three sides in a 45, 45, 90 triangle. Now, let's talk about how we know the side lengths from them. So as far as the legs are concerned, I'm just going to call one of the legs x. And it just stands for any number at all, right? It could be 5, it could be 10. Any side length can be any distance. It doesn't matter. So we don't know what it is, but in general, we're just going to call it x. Well, both legs have to be the same, so the other leg will be x as well. So they'll be the same number, whatever they are. And then in a 45, 45, 90 triangle, the hypotenuse takes that same number, which is x, but we have to multiply it by the square root of 2. And so we would consider that same level number as the leg, but multiplied by square root of 2. And so just real quick, the idea here is this. Let's say we have a 45, 45, 90 here, and we knew one of the legs was 3. Well, the other leg would have to be 3, and then the hypotenuse is going to be 3, but multiplied by the square root of 2, so 3 root 2. Another quick example would be if we knew it was 5, right? Well, then the other leg would be 5, and the hypotenuse would have to be 5 root 2. So again, this is very useful and very quick because we don't have to perform any algebra or anything like that to figure out these new side lengths if we can recognize it's a 45, 45, 90 triangle. Now, we get more patterns that arise as well in a 30, 60, 90 triangle. Again, the 90 means we're going to have a right angle in here, and then the other two angles will be 30 or 60. So the small one will put a 30, big one will put a 60. So across from the small angle is going to be the smallest side. We'll call that the short leg. And then across from the medium angle, which is 60, is going to be what we will call the long leg. Now, it's not the longest side, right? Because our longest side always comes across from our 90 and is called the hypotenuse. But our long leg is just longer than what the short leg is. And so here's the side relationship. I'm going to go with this color. Our short leg is the one we'll call x. The short leg is just some number, and that's it. Could be 5, could be 10, could be 3, whatever. The long leg is that same number, but we multiply by the square root of 3, right? Square root of 3 in 30, 60, 90. Square root of 2 in 45, 45, 90. So again, long leg is the short leg number divided by the, or times the square root of 3. And then the hypotenuse is the short leg number, so x again, but it's twice as big. So we multiply it by 2. And so, real quick example, if we had a triangle over here, and let's say we knew the short leg was 3, well then the long leg would be 3 multiplied by the square root of 3, so 3 root 3. And then the hypotenuse is twice as big as the short leg, so 2 times 3, which is 6. So that's the idea there. So now let's do a couple practice problems. Notice it says leave your answers in simplest radical form. We'll do that often, but sometimes we'll just do decimals too. So don't worry too much about it. Now, in number one, we got to recognize this 45, right? Got to recognize the 45 because that tells us this is a 45, 45, 90 triangle. We see the 90 right here, 45, 45, 90. And so we got to recognize where the information we have is, right? We have a 10. And both legs are the same. It's the hypotenuse that's different in a 45, 45, 90 triangle. And so we just know right off the bat that x needs to be 10 because across from our 90-degree angle, like that arrow I just drew, is our hypotenuse. So it's the y one that's slightly different here. The other two sides are going to be the same. So since one is a 10, the other one's 10. And then remember in a 45, 45, 90, our hypotenuse is the x root 2 part. And so y is simply just 10 times the square root of 2. Let's practice that again. In number 2, recognize the 45, right? So there's a 45, 45, 90. Across from our 90 is the different one, so that'll be y, which means since this side is 7, x is going to equal 7 as well, which makes y just 7 times the square root of 2. Because it's still the leg number, but just multiplied by the square root of 2. Now, let's move to the next one. This one's the tricky one, right? Because if we find our 90-degree angle, that tells us that where the 8 is our hypotenuse. Now, normally, we want to see our hypotenuse with a square root of 2 on it, right? But this time we don't see that. We simply just have 8. It's not 8 root 2, it's just 8. And so we you'll notice I wrote it equals x times square root of 2. And so what we want to try to do in this problem is literally solve for this x. Because that x, remember, if we look back up here, is really just the distance of one of our legs. And remember, both legs are the same. And so if we can figure out what this x is here, the one my arrow is pointing at, that'll tell us what x and y are. Because remember, that is my leg, and both of my legs in a 45, 45, 90 are the same. And so really it's a one-step algebra equation here. We have 8 equals x times the square root of 2, and we want x by itself, so we're going to divide by the square root of 2. And so x will literally equal whatever 8 divided by the square root of 2 is. Type that into your calculator, and you should see 5.7. So what that's going to tell us is x and y both are going to be 5.7 in this problem. This one just required us to work backwards. Instead of attaching the square root of 2 to a leg, we had to divide by it because we were trying to figure out what that leg was. Now, I want to give you an easier version of this kind of problem too. We could easily set this up like this. And I say this is x and this is y, and I say that our hypotenuse is, let's say, 6 root 2. Well, remember, normally the hypotenuse is usually x root 2. And so since the root 2 is already there, right, that kind of cancels each other out, meaning our x is simply just that number that's in front of the square root of 2. And remember, our x stands for a leg in a 45, 45, 90, and that's what x and y both are here. And so x would be 6 in this example, and y would be 6 as well. And so I just want to make you aware of that. Sometimes you'll see the hypotenuse with the square root of 2 attached. So then your other legs are simply just the number that was in front. All right, let's go to number 4. Let's find, this is a 45, 45, 90 again. And so our hypotenuse is the different one. And so this is normally x root 2, right? And if we already saw the root 2, it would just be that our answers would just be the number that's in front. On this one, we'll have to divide by the square root of 2 again. So our x, remember, one more time, which is our leg, which is what x and y both will be, is going to be whatever we get when we do 12 divided by the square root of 2. And when you type that into your calculator, I believe it should come out as 8.5. And so x and y are both 8.5. All right, so that's it with the 45, 45, 90s here. So let's look at the 30, 60, 90s. Remember, in a 30, 60, 90, we have 3 different kind of angles. We see a 60 here, right? So that's how we know it's a 30, 60, 90, which makes our missing one 30. So across from the 30 is always the short. And that's the crucial one because that's the one that everything's based off of, right? Our short leg is just some number. And then our long leg is that number times the square root of 3. And our hypotenuse is our short leg times 2. So we have our short leg. Our hypotenuse is always across from the 90, so x just has to be 24, because 12 times 2 is 24. And then y is our short leg number, which is 12, but then times the square root of 3. And that's it. So let's move on to 6. Again, the crucial one in the 30, 60, 90, and remember this missing angle would be 60, because we knew this one was 30, is to figure out the short leg. Across from the 30 is always the short, so 4 is our building block here. Across from our 90 is always our hypotenuse, and so the hypotenuse is twice as big as the short, and so x has to be 8. And then y is our long leg, and that's the short leg number, which is 4, multiplied by the square root of 3. All right, let's keep moving. In 7, this time, notice what we have. We have, across from the 90, the hypotenuse number. So that's normally twice as big as the short leg. So let's figure out which one the short leg is. Remember, the short is across from the 30. The missing angle would have to be 30 in this one. So where x is our short leg. Remember, the hypotenuse is always twice as big as our short leg. So if our hypotenuse is 6, if we divide that by 2, that'll tell us our short leg. So x is 3, which means y has to be our short leg number with the square root of 3 attached to it. And that's that. All right, let's move to 8. In this one, here's our 90. So the information we have is we know our hypotenuse. Across from our 30 will always be our short, and our short is half of what the hypotenuse is. So since our hypotenuse is 18, our short is 9. And then our long leg, which will be the third missing side, is the short number with the square root of 3 attached to it. And so there we go. Now 9 gets trickier. Here's why. The 30 degrees across from that is our short. Across from our 90 is our hypotenuse. And then across from 60, which was our missing one, is our long. And the long leg usually has the square root of 3 attached to it, right? But this time it doesn't. It just says 8. So we need to solve for this x value. This x value represents what the short leg is. And so if we get that x by itself, we'll know the short leg, and then we can figure everything else out. So just like before, we want to divide both sides this time by that square root. And that'll tell us what our short leg is. And so our short leg will literally be 8 divided by the square root of 3. And if you type that into your calculator, it'll tell you 4.6. And remember, this x represented the short leg. And so our short leg is 4.6. And then our hypotenuse is always twice as big. So 4.6 times 2, 9.2. And that's what y has to be. All right, let's keep moving. All right, here's another tricky one, right? We have two triangles here. Here's our 90 degree, there's a 30, which means this, and I'm going to focus on this triangle, is our 60 degree. And so across from the 90 is the hypotenuse, that's y. Across from the 30 is the short leg, that's what x is. So we have the long leg again, and normally it equals x times the square root of 3. But it doesn't, it just says 10, so we have to divide by the square root of 3 again this time. And so our short leg, which is what x is going to be whatever 10 divided by the square root of 3 is. And if you type that into your calculator, I believe we will see that that is 5.8. So our short leg is 5.8. Our hypotenuse is always twice as big as our short leg. So 5.8 times 2 is 11.6. Now, I want to add something to this problem. Just like the 45, 45, 90, sometimes on the long leg, you might see the root 3 already attached. So if they give you the long leg and they tell you it's like 6 times the square root of 3, well, remember, normally it's x times the square root of 3. So again, the square root of 3's kind of cancel here. And our short leg is just the number in front of the square root of 3, which makes our short across from the 30 be 6. And then again, across from the 90 is always your hypotenuse. If I times that by 2, I get 12. And so this is the crucial part down here. Recognize